2.8 trillion. I mean, that is just a massive, almost incomprehensible number. And as of today, it represents the exact moment the open source AI boundary was fundamentally shattered. For the very first time, developers and researchers everywhere are looking at an open model of a scale we've literally never seen before.
So welcome to this explainer breaking down the newly released Kimi K3 tech blog. Today, we're exploring the world's first open 3 trillion class model. Moonshot AI just dropped the details on Kimi K3, and wow, it is a fascinating leap forward for frontier intelligence, specifically when we're talking about long-horizon coding, complex knowledge work, and advanced reasoning. Okay, let's dive right into this. Here is our agenda for the explainer. 1. The 3 trillion parameter milestone. 2. Under Kimi K3's hood. 3. Next-level coding autonomy. 4. Digital creation and vision. And 5. Accelerating science and hardware.
Starting off with Section 1, the 3 trillion parameter milestone. If we just look back over the last 12 months, you know the race has been absolutely relentless. Back in July 2025, ZAI pushed the boundary to 744 billion parameters. A few months later, thinking machines hit 975 billion, and then earlier this year, DeepSeek shattered that 1 trillion mark, landing at 1.6 trillion parameters. But Kimi models have actually been setting the upper bound of open model sizes for 9 of the past 12 months. And now, in July 2026, Kimi K3 just leaps all the way to 2.8 trillion parameters.
Now, it is important to be objective here. The tech blog clearly notes that K3's overall performance does still trail the absolute most powerful closed models on the market right now, specifically Claude 505 and GPT 5.6 Sol. But it consistently outperforms other tested models, giving us undeniable frontier-level performance in an open package. And it does this while boasting a massive 1 million token context window and native vision capabilities built right in.
Moving on to Section 2, under Kimi K3's hood.
So, the crucial point here is understanding Kimi Delta Attention, or KDA. This is one of the core architectural updates Moonshot AI introduced. Because, think about it, managing a 1 million token context window requires incredibly optimized information flow, not just across the sequence length, but through the sheer depth of a 2.8 trillion parameter model. KDA is essentially the framework that makes a context window that massive actually functional. But KDA doesn't work alone. It's paired up with attention residuals and, critically, a massive scale-up in their mixture of experts, or MOE. You can think of this as the model only using the specific parts of its brain it needs for any given task. Within their stable latent MOE framework, the model has 896 specialized experts, but it only activates 16 of them for a single token. So what does all this dense architectural jargon mean for us? It means K3 achieves about a 2.5 times improvement in overall scaling efficiency compared to Kimi K2. It is literally converting raw compute into intelligence 2.5 times better.
All right, Section 3, next-level coding autonomy.
That immense compute efficiency we just talked about translates directly into agentic intelligence. Let's just look at how K3 operates when you turn it loose on complex coding tasks. Researchers put K3 in a sandbox and gave it 24 hours to independently profile, rewrite, and benchmark GPU kernels. On the attention residuals kernel, K3 ran non-stop for 15 hours. Operating with barely any human oversight, it designed a completely novel two-phase kernel algorithm. It managed to slash the processing time from 283.6 milliseconds down to a blistering 114.4 milliseconds. Actually, an early version of K3 handled the majority of the team's kernel optimization work during the model's own development. How wild is that? And this brilliantly illustrates just how far beyond basic code generation we've come. The team asked K3 to build a GPU programming system completely from scratch. The result? Mini Triton. K3 engineered an entire, coherent end-to-end compiler, front-end, intermediate representation passes, code generation, the whole shebang. It wasn't just writing isolated little scripts, it built a system that rivals heavily optimized industry-standard stacks, and it successfully sustained end-to-end nano-GPT training. Let's shift gears to Section 4, Digital Creation and Vision.
K3 isn't just stuck in the back-end terminal, though. Because it has native vision capabilities, it absolutely excels at tasks that blend heavy software engineering with visual reasoning. Take game development. K3 was tasked with building a 3D open-world browser game. It procedurally generated the environment, forests, a log tab and village, dynamic weather, and integrated 3D assets of a cowboy and horse. But here is the absolute magic part. It achieved true vision in the loop. It continuously looked at live screenshots of the very game it was coding, instantly seeing the visual output so it could refine its own code and fix graphical bugs on the fly.
If game dev doesn't drop your jaw, this for sure will. As a proof of concept, K3 autonomously designed and verified a physical AI chip. In a single 48-hour autonomous run, using open-source tools, K3 built a 4 square millimeter chip that closes timing at 100 MHz. In simulation, this chip sustains over 8,700 tokens per second of decode throughput. I mean, just think about that for a second. A physical chip built by an AI model, specifically intended to serve another AI model designed end-to-end in just 2 days.
Which brings us to our final part, Section 5, Accelerating Science and Hardware.
This really highlights the profound impact K3 is having on the speed of scientific research. It acts as this incredible bridge between dense academic literature and executable code. So I want you to ask yourself, exactly how fast can an AI conduct computational astrophysics?
2 hours. Now, what's really interesting about this is that for an experienced human researcher, this specific workflow, reproducing complex universal relations for compact stars, would typically take 1 to 2 solid weeks of highly focused work. Kimi K3 completed the entire process, including generating an interactive HTML dashboard to explore the results, in a couple of hours.
Rather than drowning in the 20-plus dense papers it had to read or the 3,000 lines of Python it wrote, K3 successfully navigated and evaluated over 300 highly complex equations of state. It just effortlessly handled the nuances of quark models, hadronic models, and piecewise polytrope models. It tackled this massive scientific workload with a level of autonomy that really points to a total paradigm shift in how we are going to conduct computational research moving forward.
So, why does all this matter for you? Well, because this isn't just some locked-away research project. Kimi K3 is available right now on kimi.com and through their API, running by default with max thinking effort for peak reasoning. And crucially for the open-source community, Moonshot AI is currently aligning with inference partners to ensure a smooth rollout, and the full model weights will officially be released on July 27, 2026.
We have seen K3 optimize kernels, build entire compilers from scratch, code 3D worlds using visual feedback, design physical microchips, and compress weeks of astrophysics research into a single afternoon. The ceiling of open-source intelligence has quite literally just been blown wide open. So I'll leave you with this. With the 3 trillion class model soon to be sitting on open-source repositories, what will you build?